After completing this chapter, the learner will be aware of the environmental and health risks associated with bunkering operations, know the requirements prior to commencing bunkering operations, know the startup procedures for bunkering operations, know how to carry out bunkering operations including topping off, know the requirements for sampling and testing of the fuel, including the relevant sections of MARPOL Annex 1 and Annex 6. Before we start to look at the actual bunkering requirements and procedures, it is worthwhile looking first at the hazards that are present during bunkering operations. This will help to explain why some of the procedures are in place. As we have already mentioned, the ISM code is intended to ensure safe operation and pollution prevention. The ISM code requires that companies and the ships that they operate have a safety management system in order to comply with the code. The safety management system should cover all onboard operations which have an identified risk or hazard potential, as well as identifying responsible persons and reporting and auditing procedures. These should be contained in the Safety Management Manual, a copy of which must be placed on board the vessel. The potential risks and hazards to personnel, the vessel and the environment are particularly high during operations such as bunkering. It should therefore be obvious to you that these operations will be covered by the procedures contained within the Safety Management Manual for your ship. You should always familiarize yourself with any procedures for all operations that you were involved with on your ship before starting the operations. The main hazards during bunkering operations concern health and safety of personnel, fire risk, and environmental damage. Click on the buttons to learn more about each of these. It is important that all personnel involved with the handling and use of fuel oil on board ship are familiar with the relevant material safety data sheets for the grade of fuel concerned. The material safety data sheet will give detailed information as to the hazards and risks associated with a particular fuel, including important health information and recommended treatment of victims. The main hazards to health when dealing with fuel are skin contact, eye contact, vapor and gas inhalation, including possibility of hydrogen sulfide, and fuel ingestion. Using the appropriate personal protective equipment and being careful is the best way of avoiding injury or health problems for you and your fellow crewmen. As a minimum, you should use barrier cream, gloves and overalls to prevent skin contact, goggles to prevent eye contact, face mask or respirator, and minimize time at tank openings to limit inhalation risk. And use face mask and care when connecting or disconnecting hoses to limit ingestion risk. Flammable vapors are given off by a fuel once it reaches a temperature above its flash point. The flash point is defined as the temperature at which the vapors given off can be ignited by an external ignition source. When fuel vapor is mixed with the required amount of oxygen to form a flammable mixture and an ignition source is present, then fire or explosion can occur. A flammable mixture has a concentration of vapor between the lower explosive limit and the upper explosive limit. For hydrocarbon vapors, this is taken as approximately 1% and 10% by volume, respectively. To prevent a fire or explosion, it is necessary to either avoid formation of a flammable mixture or remove any possible ignition source. Marine fuels are required to have a flash point of not less than 60 degrees Celsius, although some vapors can still be given off below this temperature. Marine oil pollution has a detrimental effect on the environment and the local ecology, harming marine life and seabirds. Major oil pollution incidents usually result from groundings, collisions, etc., and involve either tankers or vessels with large bunker capacities. You will be familiar with many of these from reports on television and the newspapers. Incidents due to bunkering operations, although not usually involving large quantities, can still, however, cause a great deal of environmental and ecological damage. This is due to the fact that most bunkering operations are carried out either in port or in near coastal waters. Every effort should be made to avoid spillages, leaks and overflows whenever bunkering, and all steps should be taken to minimize the effect of any such incidents, should they occur. Bunkering procedures should therefore not only include good operational practice to prevent these incidents, but also contingency measures should they occur. We will look in greater detail at these procedures later in the module. Some shipping companies still leave the quantity calculation and ordering of fuel to the chief engineer on board the ship. In other cases, the fuel is ordered either directly from the relevant department within the shipping company office or by the charterers who have hired the ship. Whichever is the case, it is important that the correct grades and quantities of fuel are ordered to suit the machinery fitted on board and the operational requirements of the vessel. It is also important that the vessel has the storage capacity and tank configuration to allow the quantity of fuel ordered to be received and stored in a way that avoids operational difficulties and pollution incidents. So, even if the bunkers are ordered by onshore personnel, the person responsible for the fuel on board, usually the chief engineer, will need to plan where it is to be stored. He must therefore be able to calculate the fuel remaining on board and also plan which tanks will be used for the new bunkers in advance. To ensure that the correct quantity and type of fuel is on board at any particular time, it is necessary that bunkering operations are planned correctly. This is usually the responsibility of the chief engineer, who will make his plan based on information about the next voyage. He will have to take into account various factors when calculating quantities and forming his bunker plan, such as voyage length, vessel speed requirements and therefore expected fuel consumption rate, required fuel reserve, legislative restrictions, and available storage capacity. In addition, he may have to take into account other factors such as charterers' requirements and cost and availability of fuel at future ports of call. Once the required quantity has been calculated, then the fuel can be ordered. The required grades of fuel are selected by making reference to the specification in the ISO 8217 fuel standard, currently the 2005 third edition, plus any company and engine manufacturer's recommendations. The ISO 8217 fuel standard, which is covered extensively in CBT number 179, Marine Fuel Properties 2, is the international standard for marine fuels. Many shipping companies have additional standards for their vessels. These take into account the treatment facilities on board and past service experience with different fuels. These company standards often have specifications not included in the ISO 8217 standard. The engine manufacturer's recommendations will take into account specific requirements for their engines, with particular reference to design limitations and service experience. You should try and make yourself aware of the content of ISO 8217, and also any specific requirements that your company or the engine manufacturer has for the fuel for the machinery on your current vessel. This will help you understand the handling and treatment requirements, and will also highlight possible problems you may have when using the fuels on board. Different grades of fuel may be required for the various machinery and equipment fitted on board the vessel. Even for those vessels using the same fuel for all of the machinery on board, it would be normal to carry 3 grades of fuel to meet different operating conditions. You should be aware that current air pollution regulations contained in MARPOL Annex 6 limit the level of sulfur allowed in marine fuel, with a reduced level in SOx emission control areas. With the Annex 6 amendments that came into force in May 2005, the sulfur limit of the fuel for operation within a sea car has been set at a maximum of 1.5% content by mass. Recent European Union legislation requires levels at 0.1% in some situations. It is therefore important that the vessel's trading pattern is taken into account when selecting the grades of fuel to be bunkered. If the trading pattern of your vessel includes operation within a sea car, a quantity of low-sulfur fuel will have to be carried on board. This may also be the case if the future trading pattern of the vessel is uncertain. This will normally be in addition to the regular grades of fuel required. The different grade requirements will dictate the storage arrangements on board the vessel. It is recommended that fuels from different sources, particularly residual fuels, should not be mixed in storage. In other words, new bunkers should not be loaded into a tank containing any of the previous bunkers. The purpose of this recommendation is to minimize the risk of fuel compatibility problems, which may result in the formation of sludge and heavy deposits, either in storage tanks or in treatment equipment. Mixtures of residual fuels can become unstable, even if the original fuels were stable, so mixing should be avoided whenever possible, as was stated in an earlier chapter. In practice, this is not usually possible, since fuel tanks are not normally completely empty unless they have been manually cleaned. They should, however, only contain the minimum quantity of old bunkers before filling with a new batch. Click on the buttons for more information about the different fuel grades in use. As already stated, recent changes to legislation mean that ships have to operate the machinery on low-sulfur fuel in some areas. By the end of 2007, there were 2 designated sea cars, where sulfur oxide emissions are strictly limited. These are the Baltic Sea and North Sea areas. Sea car designation will follow for other areas in the future. This requirement has brought with it many problems for the ship operator, such as supply, storage and recording of the use of these fuels. Some existing onboard storage and transfer arrangements have had to be altered to allow storage of low-sulfur fuel, so that vessels can comply with these requirements. You should check the onboard arrangements on your vessel when you get the opportunity. The use of distillate fuels in main propulsion and many auxiliary diesel engines has decreased over recent years due to the high cost of these fuels. Many engines are now designed to operate on residual heavy fuel. However, some auxiliary engines, as well as some medium-speed main engines, still use distillate fuel all of the time. Even when residual fuel is the main fuel, there is still a need to carry some distillate fuel, either diesel oil or gas oil, for operation, when, for example, heating facilities are temporarily unavailable for the heavy fuel. The 4 grades of marine distillate fuels are detailed in the ISO 8217 standard for distillate fuel oil. The actual grade required for any particular engine is identified from this standard by the engine manufacturer. The ship owners may also have their own specification for fuels used on their vessels. Heavy or residual fuels are now commonly used for most main propulsion diesel engines. It is also an advantage, as far as storage and treatment requirements are concerned, if the auxiliary engines use the same grade, although this is not always possible. The 10 grades of marine residual fuel are detailed in the ISO 8217 standard for residual fuel oil. Again, the actual grade required is usually specified by the engine manufacturer and the ship owner. Although these fuels are cheaper than distillate fuels, there is often an increased maintenance cost associated with using them, since the quality is generally not as good. You can check which fuels are recommended for the engines on your ship by looking in the engine manuals and any company instructions held on board. There are some potential operational problems that you need to be aware of when using low-sulfur fuels. Normal cylinder oils, which have high alkalinity levels, are not suitable when burning these low-sulfur fuels. The excess alkaline additives can lead to liner, piston ring, and piston scuffing due to the deposits left after combustion. It may be that your vessel now has to carry different grades of cylinder oil to suit operations on these fuels. There is also some concern that the low levels of sulfur will affect the fuel's ability to lubricate the fuel injection equipment properly. This may require additional lubrication arrangements to be provided. You should check the onboard arrangements on your vessel when you get the opportunity. Although many vessels are now equipped with remote reading contents gauges for the fuel tanks, it is still good practice to sound the fuel tanks using a sounding tape to check actual fuel quantities. Every vessel is provided with tank capacity tables. These can be in a booklet or installed on the ship's computer system. These tables contain the information to allow the user to establish how much is in the fuel tanks for any condition of the vessel. Fuel is generally ordered by volume, so the tables are usually in cubic meters. You can use the density to calculate the mass of the fuel if necessary. Using the sounding tape, we can measure how much fuel is in the tank in one of two ways: the actual depth of fuel in the tank, a sounding, or the distance from the top of the sounding pipe to the surface of the oil in the tank, an ullage. It is unlikely that the vessel will be sat in the water without any list or trim, or that the fuel will be at a standard temperature when soundings are taken. You will need to make corrections for this. Click on the buttons to see how we can calculate the ROB and correct for ship condition and fuel temperature. In order to determine the amount of fuel required, we need to establish how much fuel the vessel already has on board. This is normally referred to as the fuel ROB, the fuel remaining on board. You will probably have been involved in getting some of the information necessary for this by taking soundings of the fuel tanks. Once the tanks into which you will be loading the fuel have been identified, soundings or ullages are taken. The amount of fuel in the tank can be read directly from the table using these readings. The amount of fuel required is calculated by subtracting the fuel ROB from the amount we wish to have on board after bunkering. To minimize the risk of spillage due to overflow of tanks, it is common practice to limit the final amount in any tank to between 95% and 98% of total capacity. If the vessel is not at even keel in the water, the sounding or ullage will change as the contents of the tank shift. During the calculation, a correction needs to be made to take account of any list or trim. The trim can be worked out by taking the draft at the bow and the stern and subtracting them. The list can be obtained from a pendulum-type instrument known as an inclinometer, which is usually placed at the ship's centerline. This information, together with the tank sounding or ullage, can be used with the correction tables or input into the computer program to obtain the correct quantity in each tank. You can try using the correction tables on board your vessel to see the effect on the calculated quantity of fuel in a tank for different conditions of list and trim. The volume of fuel within the tanks, and therefore the level, will vary with the temperature. Like most substances, the fuel will expand as the temperature rises. It is therefore necessary to correct the calculated quantity of fuel in the tank for the actual temperature at the time the sounding or ullage was taken. Once again, this will be done either with correction tables or computer software. You can try using the correction tables on board your vessel to see the effect on the calculated quantity of fuel in a tank for different temperatures. There are a number of specialist bunker software packages available which can be used to assist in bunkering operations. One of these, produced by Shell, is the Bunker Calc package. This allows various calculations to be carried out automatically by inputting common fuel parameter values. You can see which calculations can be done by clicking on the 9 middle icons at the top of the picture of the Bunker Calc front page shown here. Now click on the button to see an example of one of the calculations available. The example shown here is for the calculation of specific energy. The first page shows the blank form for the required parameters. These are density, water content, ash content, and sulfur content. The values are entered into the form as shown on the second page. By clicking on the indicated icon, the calculation is done automatically. The third page shows the results displayed for both gross and net specific energy. If you have this package or a similar one on board, you should experiment with it to see the full range of calculations possible. You can also access Bunker Calc online from the web address shown here. As stated previously, every effort must be made to avoid fire and pollution incidents during bunkering operations. To ensure that this risk is minimized, a bunker checklist should be used. This will probably be part of the ISM procedures that you should follow. As stated earlier in this section, you should familiarize yourself with the procedures for your vessel before operations begin. The bunker checklist should include all of the actions that are necessary to avoid pollution from leakages or overflows and to minimize the fire risk. It will also include preparation of the equipment necessary to deal with any spills. It is essential that the communication methods between crew members and personnel from the suppliers are correctly set up and clearly understood. This should include an agreed procedure for emergency stopping of the bunkering operation in the event of any pollution or fire incident. No smoking notices should be posted, and the red signal flag raised to show that bunker operations are underway. When taking or transferring bunkers, every effort must be made to ensure no spill occurs, and that if it does, it is contained on board without causing a pollution incident. The various preparations that you must make and procedures you must follow will be indicated on the bunker checklist for your vessel. On deck, there are certain preparations and precautions necessary before bunkering starts to minimize the risk of a spill and to contain any spill that may occur. These are listed here. Set all valves and lines to ensure delivery to correct tank. Fit all deck and save all scupper plugs and covers. Position any portable trip trays correctly, and prepare SOPEP equipment for use. Click on the button to find out more about SOPEP. All oil tankers over 150 gross registered tons and other ships over 400 gross registered tons are required to have a shipboard oil pollution emergency plan. Ships over 150 gross registered tons carrying noxious liquid substances, for example chemical tankers, are required to have a shipboard marine pollution emergency plan. These plans contain the actions and procedures which are considered necessary to avoid or minimize pollution in the event of a spillage or other incident. The equipment necessary to achieve this should be stored in a separate locker, clearly marked for this purpose. When taking bunkers, the equipment is prepared for use prior to start of the bunkering operations. One section of the bunker checklist will normally include SOPEP preparations. You should make yourself aware of the location and use of the SOPEP equipment on every vessel you work on. As well as any SOPEP requirements, the equipment needed to collect fuel samples is also made ready at the bunker manifold. We have seen that one of the items in the SOPEP section of the bunker checklist is to check the lineup of valves in the fuel transfer system. The valve positions required are usually included in the bunker plan for a particular bunkering operation. This plan should be used as a guide and checklist to ensure that the lines and valves are correctly set so that the fuel goes to the intended tanks. Although much of the bunkering operation will take place on deck, there will be some preparations necessary in the engine room. The actual engine room requirements will vary from vessel to vessel, but the items shown in the list may need to be considered. It is likely that engine room personnel will be involved with taking soundings and ullages, as well as monitoring progress throughout the bunkering operations. This will include topping off and changing over tanks. Communication with the bunker supplier before and during the bunkering operation is very important. The supplier should provide a bunker delivery note with full details of the fuel specification prior to bunkering. This should include a statement of MARPOL Annex 6 compliance. Before starting bunkering, agreement should be reached with the supplier regarding the required flow rates for starting, bulk delivery, and topping off. It is also necessary to agree how instructions should be communicated during the bunkering operation. In particular, arrangements and signals for emergency stopping of the operation must be agreed. Once all preparations are completed, we are ready to start taking bunkers. If there are any problems with hose connections or valve settings, it is likely that they will show up at the very beginning of the operation. An agreed slow rate should be used when starting, so that all connections can be checked for leakage, and to see that the fuel is going to the correct tanks. Only when you are sure that everything is as it should the rate be increased up to the agreed maximum rate. Remember, the person at the manifold is in charge of operations at this point, not the supplier. There is no point in taking a sample of the fuel being delivered unless it is a representative sample. There are accepted procedures for collecting, labeling, distribution, and onboard retention of the sample. You should be aware of the requirements for your vessel and follow them carefully. It is recommended that only the correct containers are used for samples, and that the sample is obtained by a continuous drip method, so that it represents the fuel delivered throughout the bunkering operation. This list shows the samples that are required. Click on the buttons to find out more about the samples. It is now a requirement that a sample is taken for MARPOL Annex 6 purposes. The sample has to be specifically for the purpose of meeting the MARPO regulations. It must be stored securely and retained on board for at least 12 months. The sample should be taken at the ship's inlet manifold, and the sample bottle must be properly sealed on completion. Details of the sample bottle serial number must be added to the bunker delivery note and entered into the oil record book or logbook. There should be documentation on board your ship giving the full requirements of these regulations. Onboard testing is not meant to give accurate results, but should give a rough indication for the main parameter values of the fuel. Typically, onboard testing is carried out using simple test equipment. The parameters that are usually tested are shown in the list. The results from these tests will give an early indication if using the fuel is likely to cause any operational problems. Take the opportunity to do these tests using the fuel on board your vessel so that you become more familiar with them. Many ship operators make use of a specialist fuel analysis service to get detailed information on the quality of the fuel delivered. The major classification societies offer this service and usually supply the containers, labels and instructions for taking and forwarding the samples. The analysis report covers the fuel properties and contaminant content. It also gives advice on storage and handling and predictions on the effect of using the fuel. It is also good practice to carry out onboard testing of the fuel as a check on the accuracy of the shoreside analysis report. It is important that the bunkering operation is closely monitored from start to finish. This not only requires that tank levels are monitored continuously, but also that someone is on station at the manifold to check the hoses, connections and pipelines for any leakage. Tanks should be sounded regularly during the operation, and particularly when topping off and changing over tanks. Even those tanks not being filled should be checked to ensure there is no leakage past valves into them. These requirements should be included in the bunkering procedures laid down in the ship's safety management manual as required by the ISM code. As part of the bunker plan, there should be clear, detailed instructions regarding the necessary actions for completing the bunkering operation. As the first tanks approach the required level, the valves should be opened for the next tanks to be filled. By controlling these valves, the filling rate of the first tanks can be slowed down. Once the required level is reached, the valves for the first tanks can be shut, allowing the full flow to pass to the second tanks without interruption to bunkering. When the final tanks are close to the required level, the rate should be slowed down to allow controlled topping off. The supplier should be informed and be ready to stop delivery. At completion, all valves should be closed, any blanking plates refitted, and all tanks should be sounded. Quantities can then be calculated and agreed with supplier. You will now hopefully appreciate that it is necessary to closely monitor the entire bunkering operation. Since bunkering operations are the source of a majority of pollution incidents involving fuel oils, it is necessary that every precaution is taken to avoid pollution incidents. We have looked at the various requirements and procedures that are in place to minimize the risk of pollution during bunkering. You should now have a knowledge and understanding of these procedures. Remember, everyone on board the ship has a responsibility to do everything possible to avoid pollution. It is up to you to ensure that you are aware of the requirements and procedures that apply to your ship.